Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, thank you once again for joining Industrial Talk, the #1 industrial-related podcast in the universe that celebrates industry professionals all around the world. You are bold, brave, dare greatly. You innovate, you solve problems, you make the world a better place. We truly appreciate you here at Industrial Talk. And we are broadcasting on site. IoT Solutions World Congress, Barcelona, Spain is the location, and I cannot stress this enough. You need to put this one on your calendar for next year. If you're not here this year, you're missing out. Be here next year. This is where all the cool kids are hanging out in the world of IoT. Stan, can I say cool kids and IoT in the same thing?
Sure.
Whatever. Sure.
I
there
give
it
you
is.
permission.
There he is. Stan has given me permission. And Stan is in the hot seat. And Stan has been on this platform a number of times talking about Stan stuff. So let's get cracking. Let's get cracking. Stan stuff. It's been a
Great.
good.
Thanks for having me here.
Yeah.
I'm going to talk about Scott stuff.
No,
today.
I don't want to talk about Scott stuff. Stan stuff. Stan stuff sounds so much better, and you're far more intelligent than Scott stuff.
I didn't mean you. There's lots of Scotts on the planet.
There's a lot of Stans, but no, this is specific to you, Stan. So you having a good conference?
Yeah, it's pretty good.
Yeah. Do you have a booth here?
No.
Or are you just sort of wandering?
No, I hosted a session and I have a talk today.
What you talking on?
Talking on data-centric technology for teleoperation. We've recently been doing a lot of work with automotive systems. We've been working in autonomous vehicles forever, and one of the things you need to be able to do is get them unstuck. I'm actually talking with one of our customers, ESA, European Space Agency, that has been working for a very long time on teleoperating space rovers, robots on Mars.
Yes. I didn't never thought of it. Yeah.
So it's it's sort of leading edge research, robotics, and it's surprising that there's actually quite a bit of commonality between that and what we see with a lot of our customers doing similar kinds of vehicle stuff.
I was having a conversation with somebody specific to autonomous vehicles, and just the amount of code, the sophistication to make it autonomous is just through the roof.
Yeah.
And then, of course, we had the cyber conversation, and of course, that's a big deal too as well. But it's happening, right? We're going to have autonomous vehicles, right?
Yeah, if you can define them, it's happening. So, I mean, autonomous.
You want me to define it? I get in and I go, and I don't have to do anything, and it gets me to point B.
Is it snowing? Are you on dirt roads? Are you able to go through?
See, I'm just a consumer. I just want to go to point B. I don't care what the conditions are. Autonomy
is like happipiness. You can never be fully happy. There's no such thing as fully happy, and there's no such thing as fully autonomous.
Oh, that's interesting.
It's a range. I actually, you've heard the level 1, 2, 3, 4, 5. I'm not wild about those levels because it really, really matters about the environment. Just like happiness, you can be happy at work and not happy at home, or vice versa.
Yeah.
It really depends on where you are and what you're trying to do.
What are they thinking through? I mean, let's say I'm all in. There's the autonomous vehicles. I'm a consumer. I'm not interested in knowing how the sausage is made. I just want to get into that vehicle, and I wanted to go to B. Is that even plausible, or is there going to always be this responsibility on my part where it's sort of semi-autonomous, but I better stay alert because maybe that autonomous wants to not be autonomous, and I'm going to have to be called into action?
Ever's a damn long time, okay? So will it ever happen? Of course it will. I mean, it might be 5 years, might be 50 years, it might be 500 years, depending on how you define autonomy, but it's absolutely going to happen. Technology moves forward. It's an obviously compelling use case in many different kinds of things. Some things will happen earlier. The easy environment thing. So we've been doing autonomous vehicles. It's not all we do by any means. We have over 250 designs of autonomous vehicles. Only about, 10% of those are road vehicles that you could get into, maybe 20%.
Huh.
Most of them are, we started out with flying things, or 100 different kind of flying things. Much easier to fly, by the way. Flying things, underwater things, surface things, mining vehicles, construction vehicles, forklifts, delivery robots, on and on and on and on. They're all autonomous vehicles. I just define a vehicle as something that moves and can operate for some period of time without help. The great definition, the sort of academic definition of autonomy is how long you can go without a greater intelligence helping. Even you aren't fully autonomous, Scott, because you probably need help every now and then. And so,
yep, don't talk to my wife. Yep.
I mean, it's just you gotta look at autonomy as a level of intelligence and a level of fit to the environment. And if you fit the environment well and you're quite intelligent in the environment, then you're more autonomous, but you still may need help, direction, something along the line, and that we call teleoperation. It's not, that's another thing there's many different kinds of, right? It can be strategic teleoperation. Normal people think of teleoperation, you're sitting in some, office somewhere driving a car, which is not a very compelling use case, because if you're going to drive the car, you need to have full attention on what's going on. You might as well be in the car. It's not that big a deal. And if the car happens to be on Mars, well, that makes more sense.
That's true.
But if you're, if the car can handle many things on its own, every now and then it needs help, or, truck's a better example. It can handle the freeway part well, but it can't do the last mile pickup and delivery on the end. You can pick up and do teleoperation for those segments, and it makes more sense. The real hard part of teleoperation actually turns out to be the handoff. When do you hand off? How do you hand off? Where is that operator center? All those kinds of things get hard.
But it's happening.
It is happening. It's happening. It's been happening for a long time, and it will keep happening. When can you ride in a car on your own? You can go to San Francisco and ride in a Waymo car right now. It's become the hottest tourist attraction in the city.
Really?
Yeah, it's on TripAdvisor. I think it's in the top 5 tourist attractions. Take a ride on Waymo.
No way.
But
clearly,
is it practical? Is it profitable? That's a long ways from being what you want, what you're talking about.
But from an autonomous point of view, we have autonomous vehicles in production now, right? In commercial operations.
There's a few, are profitable.
Why are you in this autonomy? You're all into it, but
no. So we do a lot of road vehicles. Only maybe between 5 and 10% of them are shooting for high-end autonomy. Most of them are building what's actually much bigger disruption in the industry called software-defined vehicles. It's really a completely different way to think of how to make cars, and it's tearing the industry into pieces.
Why? I don't understand. Why is that?
So if you have a reasonably recent car today and you look inside it, it's going to have 400 or 500 little computers called ECUs, electronic control units. That each do something. Usually some very well-defined thing, and they're connected together over what I would call a stupid network CAN bus. I'll get shot for calling it stupid. But compared to Ethernet or a high-bound bandwidth network, it really isn't very flexible, with a very simple interface. So if you're doing, for instance, a smart cruise controller that's watching the car in front of you with a radar, all that thing is going to do is take a speed you want to go, so it won't go faster than that, and it'll tell basically the car speed up or slow down. It's the only interface it has, and that's great if that's all you want to do. But if you want to use that radar signal, which could have a lot of information to differentiate the car and the pedestrian and something else, you can't really do that, because that's not what that little part does. So anyhow, if you look in your car today, you'll have 400 or 500 ECUs. They're all software that was built before the car went into production. To replace or fix a bug in the software, you have to do a recall. Recall's a dirty word in the auto industry. It's
right off the bat, when you said that, I just said, "Oh no."
The only way they can fix is to replace the hardware part. It's sort of insane. So that's sort of the way cars have been built forever, and it also is the way the industry supply chains are set up. Right? You've got these tier 1s and tier 2s, and what they do is they take these specifications for a smart cruise controller, and they make a smart cruise controller, and you can buy it from Bosch or Conti or Magna or whatever and put it in your car. That's sort of the way the world's set up. But software doesn't work that way. So a software-defined vehicle, a huge contrast. Instead of having all these lots of little computers, you'll have one or two, few big computers, maybe one big central one like what Tesla did, maybe smaller big ones, it's called zonal architecture, that really are, their biggest goal really is to reduce the wiring. Wiring's the third heaviest, one of the top three most expensive parts of a car.
Oh, I didn't know that.
And you can get rid of a lot of the wiring just by putting compute power out in the zones of the
in
car,
the area.
like the right front area or whatever,
right.
And then connect to that with a high performance bus, and now you can update that software. So Tesla put everything in the central thing. They can update everything. It's amazing what they can update.
Huh.
But that they don't have this whole supply chain and the transition from this ECU-based, which nobody calls hardware-based, I don't know, to a software-based design, software-defined vehicle is what it's called, is just absolutely transformative in the industry. I mean, there's another huge disruption going on with electrification. Getting rid of the gas engines to electric. But this is at least a larger thing. Of course, if you're trying to make it autonomous and smart, you need high-performance computing, and that's another thing you can do with a software-defined vehicle. But most of our customers are just doing a new architecture called the EE architecture for the vehicle to make a new kind of vehicle. And that's really what our company, my company, RTI, Real-Time Innovations, we're actually the largest infrastructure software company for what we call the smart world, which I can define quite well for you. The smart world is taking large systems and making them much more intelligent. So we do things like autonomous
define
vehicles.
Large system. Like what's a large system?
Oh, we run Canada's air traffic control system. We run NASA's launch control system. We actually run the power balancing for the western grid of North America. Those are very large systems.
Yeah, those are large systems.
We also do a lot of medical robotics, billion-dollar programs. We do medical patient monitoring systems, imaging systems, lots of renewable energy, defense systems, over 400 defense programs of record, all the data flowing through like an aircraft carrier combat management system, trying to keep it from getting shot down. That's what we do. We're trying to build these intelligent, distributed, very super reliable. It gets really hard when it has to not fail, right? Most systems, like even this show, which is sort of turned into what I call the monitoring. There's really 3 markets in IoT, by the way. That in a second.
You got to go down that. I'll
go down that aisle, but okay, with 3 markets, let me go back to the other one later. The three big markets, and I don't have great names for them, but we've been calling what you see here, where you have lots of little devices that are all connected to a single cloud server.
Right.
The monitoring market. It's the biggest market in a lot of ways because it's the easiest market. So your Nest thermostat.
Sure. Yeah, that's exactly correct. Yeah.
They're really mostly just monitoring things. Well, you can control things, but it's one little device. Those devices don't share information very much except with the cloud. And overall, it's really just making those little things smarter.
Yeah.
The second big thing is sort of analytics, distributed analytics, where you take a single thing like a pipeline or a factory, and you sensorize it, put 1,000 or 2,000 sensors in it, and you collect all that stuff and get it up in the cloud as big data and think about it. And you're going to think about it to make that factory run better or decide what it's going to do later. But it's not directly changing and controlling the machines. It's just making it smarter overall.
Right.
Sort of optimizing things. There's not a lot of that here, although you will see a lot of people selling sensors that you would buy 10,000 of them, put them in a factory.
Yeah.
But that's a completely different market, and it's dominated by the cloud players that are trying to provide the data analysis and big data, and
Right.
And then the third thing.
Right there.
Yeah, AWS is a good example. The third thing you'll see a lot out there is what we call edge autonomy.
Oh yeah.
Where you're trying to make something work differently than it used to, and typically smarter, more autonomous. That's where we play as RTI, trying to autonomous vehicles, smart transportation systems, a Navy ship, whatever. Those are all single things that you want to make run better as a
But
system. Very different than the other two things, right?
Yeah.
And the biggest thing that, I can ask 5 questions and tell you if you need our software. And you don't have to know what I do, and I don't have to know what you do. It's really, so...
Right off the bat, I
Right
would
off the
fail
bat.
number 1.
So question number 1, is it a big problem? Like maybe front page news or a complete failure of the system if it stops for 1 minute. 1 minute. So if you look at most of the sensors here where they're doing power monitoring or temperature, thermostat or whatever, it doesn't matter if it's down for a minute. You wouldn't even notice it.
Right.
But most websites, they don't care if they're down for. That's the first question. Second question, you don't have to know what I do to do that. Have you said the word millisecond in the last 2 weeks? Because if you haven't, then you're probably either at human speed or below, and human speed or below, there's lots of ways to solve things that don't require this kind of data-centric world I haven't got to talk about yet. Very fast communications of information between devices. Third question, and you started with this with the code. Do you have at least 10 people on this project that write code for a living? Software engineers, I don't care what you call them. All they do is they write code.
Cool.
And as soon as you have that, as soon as you get to about 10, it's really before 10, but your cost and your success is driven by software integration. People don't see that in this industry. They do in many other industries. Software integration becomes absolutely the defining characteristic of your success and your cost and everything going on. And what we fundamentally sell is software integration technology, which is why we ask that. Fourth question is harder to ask, but really is it, are you doing more than just collecting data? Is data something static that you can collect? If all you can do is, if you want to just collect data, there's other easier ways to do that. If you want to act on it right now, get the right data to the right place at the right time, and there's many places. Typically, I used to just ask, are you sending data to more than one place, knowing what that meant? But really, if you collect data, you want it all in one place. If you're using data to do something in real time, like control a vehicle going down the road or, keep airplanes from crashing, then you need to have it now. It doesn't really matter where the pedestrian was 3 minutes ago.
And you don't want latency.
Right.
You don't want that.
You have to have low latency, and you have to have low latency to multiple points. Very rare you want just one thing with low latency, but whatever. And then the last question, which is why we're a pretty good sized company. We're the largest software company, infrastructure software, but we're about 300 people instead of 30,000 people. Are you willing to build a new architecture? Because if you ask the first 4 questions, yes, you can't do it with your architecture. It's something most people build these system-focused architecture. Where am I going to put the server? What networks do I need? When they really need a data-centric architecture. What data do I have? Where does it have to get? Put that together first and then decide if you're going to have servers at all, which is usually a problem on the edge.
I have to ask this question. It seems to me that it would be easier to achieve what RTI provides at a beginning of a project. Like you have this conversation and you're designing it in such a way that achieves what needs to be achieved, and it satisfies all of the questions that you. But how do you retrofit something that has been in production for, like, let's take an aircraft carrier that's been in out there in the ocean for a little while, and you're trying to
rip all the electronics out.
Yeah.
No, sir. Our customers have 3 things in common. First thing they have in common, we sell an architecture. It's very difficult to retrofit an architecture. Not that it hasn't been done. We're running Grand Coulee Dam. It was built in the 40s.
Yeah, there you go. That's a great example.
I can tell you a whole story of Grand Coulee Dam if you want. It's fascinating. But they ripped out all the electronics and completely changed its mission. It used to just produce energy. That's all it did. Today, its main mission is actually balancing the grid with all the solar and wind.
Sure.
So Grand Coulee is the largest power plant in North America. Everybody knows that. It's also the fastest power plant of any size in North America. Meaning it can take its 7 gigawatts of power on and off the grid in about 10 minutes.
Oh yeah,
and there's nothing else that can. You can't do that with an oil-fired plant. It takes many hours to safely shut it down. You can't just stop putting power out. It'll blow up. nuclear plants can take days to safely shut down. The gas peakers,
they're faster,
very fast, but they're very small. And so whatever, they're using the hydropower portfolio now to balance the grid as wind and solar, which are,
challenging.
They're clean energy but dirty power.
Yeah, it's challenging. They suck bars, and they have some problems.
Right, they're clean energy, but they're dirty power because you can't count on them at any time. You can count on things like solar going away at night. It happens every night.
Yeah.
Hasn't
guaranteed.
Been fixed yet. Guaranteed, yes.
Yeah.
And right about the time when all the power demand is going to the peak.
Yeah.
Is when it's shutting down. Which is another whole problem.
Yeah, exactly.
Right.
You got a friend going on over there.
Got a bug.
Yeah.
Right. That's why you do software.
Yeah. So it's hard to. It's a challenge to retrofit.
Right. So first thing, they're all doing something new. Second thing, to build that new architecture usually costs $100 million or more. 200 million. We have customers who build an autonomous vehicle. It costs billions. I'm not kidding, billions. So making that decision is risky and it's scary and it's a big project. And because of that, it's new and it's expensive and risky and scary. And most people are betting their careers at least on it. The third thing they have in common is they're all terrified. Every one of them is scared. and our role in this industry is sort of be the safe. We sell trust. We try and provide the trustworthy partner that's been through this literally thousands of times. We know what you're likely to run into. We can help you out with it. That's our role.
Yeah. See, it's a brave and exciting new world.
Smart new world.
Smart new world. I do like.
Call it the smart world.
It's just smart.
We've been looking for a name for it forever. Maybe you can help us out. You're a media person.
No.
The smart world, to me, is defined as smart systems that work together to do something better. And we need a smart world because today's world is pretty stupid.
Yeah.
It truly is. I got to get rid of this fly.
I know. Yeah, get that fly out of here.
I will.
The reality is that everything now smart. The term smart is becoming that miscellaneous file again, because now all of a sudden everything wants to be smart. And it's not bad. I have no problem with it because I'm all into smart.
Right.
But then all of a sudden it becomes sort of hazy on this.
Yeah, we can use intelligent instead if you like.
There you go. Right here, right now. Industrial talk, intelligent part. Son of a gun. Well, I
don't know what else to call it.
No.
It's more autonomous. It's also more intelligent. Another definition.
Stan, we've already burned through a bunch of time. See? You never disappoint.
I didn't even need you. I could talk 20 minutes all by myself. I'm sorry. I didn't
No,
need it.
no. It was great. I knew I could just sort of pull the string and push play or whatever you want to do it, and everything would have just went. I don't know. It's just an interesting time. Your perspective is so valuable. I really appreciate it. Yeah, when you walked up and said, "Hey, I'm here." Yeah, I said, "Oh my gosh,
great.
check it out."
Scott, you've been an icon at this show for a long time, and lots of other places. I love your podcast.
Oh, thanks. This has been great. Hey, how do they get a hold of you? They want to be able to get a hold of you.
The easiest way is connect with me on LinkedIn, Stan Schneider. Just got a number, but pretty obvious who I am from RTI, or you can send me an email at stan@rti.com and at rti.com, and I promise to read it in about 2 months.
Or you can just go out to Industrial Talk, type in Stan, and his other podcasts, his other interviews will pop up, and he'll have all the contact information for Stan there, because we're going to have it out there.
Stan Schneider, LinkedIn, easiest way to connect.
All right, listeners, we're going to wrap it up on the other side. Again, connect with Stan. You can tell we're just barely scratching the surface on what Stan knows. And he's there to help you. He wants to collaborate, make it happen, Captain. We're broadcasting from IoT Solutions World Congress, Barcelona, Spain. It is a wonderful event. Put this on your calendar. Stan's been going here for how many years?
I was actually the vice chair of the IIC steering committee that founded this thing. I was about 10 years ago, I guess.
Yeah.
8, 9 years ago.
Well, it's been through a lot of change.
Been through a lot of changes.
Yeah. All right.
And the pandemic. Don't forget the pandemic.
Oh, God. All right. We're going to wrap it up on the other side. Stay tuned. We will be right back.
Yeah.
You're listening to the Industrial Talk Podcast Network.
Yeah. Stan is the man. That is a download of Stan's stuff. You need to get a pencil and paper. You need to write that stuff down or go back, listen to it, because Stan's stuff never disappoints. Stan never disappoints. He's amazing. He thinks through all of this stuff. It's cool. It's really cool. I really enjoy. IoT Solutions World Congress was the event. You get people like Stan as you go to that event. It makes sense. You're in the world of digital transformation. Are you in the world of just all of that? Yeah, that's an event for you. Make it happen, Captain. All right. I have to apologize because we had a video glitch, so you're not seeing Stan as much as you should be able to see Stan. But we prevail. The talk is good. We are building a podcast right here. You need to tell your story? You come to Industrial Talk. You need to highlight your technology? Come to Industrial Talk. It's all here. Be bold, be brave, dare greatly, hang out with Stan. Change the world. We're going to have another great conversation shortly, so stay tuned.